Will now be recorded.
Good morning, all of you. Amarnath, Divya, Karthik, Likit, Rohit Pavan,
Good morning.
Sandeep, Shashank. I hope everybody can able to see my screen.
Yes.
Yes. Am I audible, guys? Right. Yes, good morning. Okay, welcome to Mohansh Technologies. And today we are going to be discussing about different kind of machine learning algorithms. So in the last class, we discussed about types of machine learning algorithms. So there are a few kind of machine learning algorithms which are going to be available. Okay. What are the different kind of machine learning algorithms? What are the different kind of machine learning algos? The one is supervised learning, and the one is unsupervised learning, and the one is reinforcement learning. What about supervised learning? Anybody? What is supervised learning, guys? What is supervised learning? What is a behind scene of supervised learning? And what is the behind scene of unsupervised learning? What is the behind scene of unsupervised learning? Unsupervised learning. What is the behind scene of reinforced learning? Reinforcement. There is a one more thing called reinforcement. Reinforcement, nothing but something like imagination. Reinforcement, something like a trial error process. Come to the supervised learning. A supervisor is there, and your data is labeled data. Your data is labeled data in the part of supervised learning. And unsupervised learning, your data is unlabeled data. There is no labels for the data. There is no attributes for the data, but data is going to be separated. Data is going to be predicted even with unsupervised learning. And for reinforcement learning, something like a trial error process. So just like attack with the situation. And if you are success, then you will get be rewards, and algorithm can get rewards. If it is failure, algorithm get some penalty kind of thing. Okay, let me go through this. This is labeled data. Labeled data. Labeled. This is labeled data. This is unlabeled data. In last class, I discussed about this one with examples. In last class, we discussed about supervised learning, unsupervised learning, and reinforcement learning with examples. Like you take a basket, you take a fruits and vegetables, and every fruit and every vegetable have some name. Then that is supervised learning, and it can make separate or it can make product. Unlabeled data, nothing but you box is having some fruits and vegetables, but I'm not giving the labels for them. Based on the shape recognition, based on the pattern recognition, it can predict something or it can make separation something. That is unlabeled data, unsupervised learning. And come to the one more thing, reinforcement learning. This is something like a trial error, and something like a just like attack on the situation. Okay, attack on situation. Attack on situation. That is a kind of reinforcement learning. These three are very, very important types of machine learning algorithms. Okay, for machine learning, basically there is a library called scikit-learn. I already told you there is a important library called scikit-learn. We have to work on scikit-learn library. So you can search for scikit-learn in the browser. You can search for scikit-learn in the browser. Scikit-learn. Scikit-learn. Okay, just go for scikit-learn. Official documentation for scikit-learn is scikit-learn.org. scikit-learn.org. That is the official website. That is the official website for the scikit-learn. Yeah, good morning, Amarna, Divya, Karthik, Likit, Mansa, Rohit, Sandeep, Sudesh. Okay, let me open the official documentation for the scikit-learn. It is wait, it is loading. Yeah, okay. Can you see? This is the scikit-learn machine learning algorithm where you will be having a classification models, where you will be having a regression models, where you will be having a clustering models. Can you see the picture? By seeing the picture, you can able to understand what is the classification. By seeing the picture, you can able to understand what is the classification here. What is the classification? Can you see different boxes, different kind of patterns? The first box, one kind of pattern. Second box, one kind of pattern. Third box, one kind of pattern. Fourth box, one kind of pattern. Classify the data. Example for the classification is what I told you yesterday. There is a basket. There are a number of objects inside. Okay, classify them. Red color objects into the one category. Green color objects are in one category based on the attributes. It is classification. Classify. In this, there is a one more important application types: spam detection, image recognition. Spam detection, image recognition is the classification model example or applications. There are few algorithms which are going to be available there for that. Something like gradient boosting, nearest neighbors, random forest. Okay, there are huge number of libraries which are available here. Huge number of libraries, models which are going to be available here. But I will give you the best or important algorithms in the supervised, and I will give you the best algorithms in the unsupervised learning, and I will give you the best examples for the reinforcement learning also. Okay, in the picture, I will draw something. What is supervised learning? Labeled data, I already told you. Labeled data. But what are the different kind of algorithms? What are the different kind of algorithms which are available for the supervised learning? Let me write down one by one. Few important models, few important algorithms, few important algorithms in supervised learning. One is linear regression. Linear regression. Okay, linear regression. Linear regression. What is this model basically, guys? What is this model basically? There is one simple example I will tell you. There is one simple example I will tell you. If I am giving the data to the algo for this linear regression, if I am giving the data, I already told you, no, house price prediction. House price prediction. You are giving the number of bedrooms, you are giving the number of square feet, and you are giving the age of the house. Kind of attributes we are providing to the machine. Machine trained by the data. Okay, this number of bedrooms and this age and this much square feet. The house price is this. One bedroom, 500 square feet. Age of the house is 12 years. This is the price. Two bedroom house, two-bedroom house, and age of the house is 10 years, and square feet is 600 or 800 square feet. That is one price. Okay, so input I am giving, output also I am giving. Input is what here? Input is what? There are attributes for input: number of bedrooms, age of the house, square feet. All these are inputs. All these are inputs. Output is what? Based on these attributes, some price was decided. Some price was decided. Okay, we are providing the data, huge number of data to the machine with the number of bedrooms, number of square feet, and age and all. Some price we are defining. Okay, this is the input data we are providing to the machine, and train the machine with this kind of data. Test the machine with some imaginary attributes. Test the machine with imaginary attributes. So while the testing, it is giving the accuracy price. It is giving some accuracy price of the particular existing prices of the existing attributes. That is a kind of linear regression. That is a kind of linear regression. Am I clear, guys? It is a kind of linear regression. Then one more is logistic regression. Logistic regression. Okay, I will explain all this one by one. So what is the example for the logistic regression? How we can able to work with the logistic regression and all. Logistic. What is the meaning of logistic? Something like divide the data. Divide the data. Divide the data based on the patterns. Based on the attributes or based on the patterns, divide the data. Customize the, what is it? Separate the data. That is something like logistic. In this logistic regression, you have the answer like 0 and 1. Okay, tomorrow rain will come or not? And what is the weather of tomorrow? For example, yesterday, previous days, these are the attributes of the weather, and this is the centigrades of the degrees of the weather is available. So these kind of situations, this kind of weather is available. Rain will fall or not? Rain will fall or not? Something like how the weather will be in the rainy season, how the weather will be in the summer season, how the weather will be in the winter season, kind of things. So in logistic regression, output will be zeros or ones. Zero is something like not available. One is something like available. Zero is something like died. One is something like alive. For example, if you take a COVID data, this number of parameters, a person is alive. This kind of parameters, person could not be alive. These number of parameters, he is the batter. These number of parameters, he is not batter. Something like that. This is a kind of logistic, is a kind of 0 or 1. Output is 0 or 1. How many zeros are coming, how many ones are coming. Based on that, that logistic is going to be checking like available or not, yes or no, true or false, kind of thing. Or zeros and ones come, something like that. Yeah, go ahead. Any questions? Amarnath, Deepak, Divya, Karthik, Likit, Manasa, Rohit, Sandeep, Shashank, Shravan, Sriya. Any questions on this? Linear regression, a kind of data different. Logistic regression, a kind of data is different. Next, the one more important model here is decision tree. Decision tree. This is also kind of uh, model. I will explain all these models one by one. First of all, we will write down all the algorithms which are very famous and very useful in the real time. In supervised learning, linear regression is there, logistic regression is there, decision tree is there, random forest is there. Random forest. How this will be work out? Random forest. How this will be work out? And one more is support vector machine, SVM, support vector machine. And one more is KNN algorithms, K nearest neighbors, K nearest neighbors. These are the things. And one more thing is Navi basis, Navi basis, Navi base, basically base, Navi base. This is the one more kind of algorithm in the supervised learning. The most important models, most important algorithms in the supervised learning part. And come to the unsupervised learning. Come to the unsupervised learning. What are the different kind of unsupervised learnings are available? What are the different kind of unsupervised learnings are available? Unsupervised learning is what? Unlabeled data, right? Model learns patterns from the unlabeled data. Modern learns patterns from unlabeled data. Your model learns patterns from unlabeled data. Let me go. What are the different kind of unsupervised learning algorithms? Most famous things. One is K means clustering. K means clustering. K means K means clustering. K means clustering. Please mute, sir. Please mute. Who is this? Please mute all. Karthik, please mute. Okay. Come to this unsupervised learning. The first important model is K means clustering. So how the data will be given for this, I will tell you. And one more thing is PCA, dimensionality reduction. Dimensionality reduction. Dimensionality reduction. Sir, I will give you simple examples for all these algorithms. Don't worry with the data sets. Okay. One is the dimensionality reduction. One is the hierarchical clustering. Hierarchical clustering. Hierarchical. Hierarchical clustering. Clustering. The one more thing is association rules. Association rules. Association rules. So these are the important unsupervised learning models. These are the important unsupervised learning models. One is K-means clustering, dimensionality reduction, PCA, hierarchical clustering, association rules. Am I clear, guys? Any questions on this? Come to the reinforcement learning. One simple example for reinforcement learning. Yesterday I told you. Yesterday I told you one simple example for the reinforcement learning. What are the different kind of examples for the reinforcement learning? Self-driving cars. How these self-driving cars are actually detecting the objects, finding the patterns, detecting the images or detecting the objects, detecting the environment. Reinforcement learning is on top of the environment, the kind of algorithm which is going to be working like. And one more thing is something like a chess application, online chess gameplay, game playing like chess application, chess or Go. That is a one more example for this reinforcement. And one more example I told yesterday for the reinforcement. What is that? One is self-driving cars, one is game playing, and one more example. Yesterday I told you, na, small kid touched the fire. Second day, he got some experience. He already pain with the fire. That is the why reason he don't touch the fire. What is the kind of object it is? Robots. Robots. How robots are learning by the experience. How robots are learning by the experience. Preparing the robots, generating the robot algorithm. That is the kind of reinforcement learning. Am I clear, guys? First of all, supervised learning, unsupervised learning, and reinforcement learning. Any questions on this? Please let me go. Let me know. Any questions on this?
No, sir.
Right. Now, the kind of machine learning workflow. What is the workflow for the machine learning? Any algorithm you write, like supervised learning or unsupervised learning or reinforcement learning. What is the workflow for this? What is the workflow for the ML? What is the workflow for the ML? Yesterday, I given a small introduction for that. Yesterday, I given a small steps for that in the architecture of ML. In the architecture of ML, I given some simple things. Collect the data. Collect the data. The next one, clean the data. Sir, mute, sir, mute. Clean the data. Cleaning means what? Remove the null values. Remove null values. Remove nulls. And one more thing is duplicates. Duplicates. And one more thing, unwanted columns. Unwanted columns. Unwanted columns. This is a kind of cleaning data. Cleaning data procedure. Cleaning data. After cleaning the data, there is a one more important concept here is feature engineering. I will tell you what is this feature engineering, Feature engineering. Feature engineering. Feature engineering. There is a one more important concept called feature engineering here. The first step is collect the data. Second step is clean the data. Third step is feature engineering. Then one more important step I told you. One more important step I told you. Split data. Split data. How you are splitting the data, sir? How you are splitting the data? Train set, and test set. train set, test set. Your data set is there. Your data set have 100 records, but your 100 records splitting by trained data set and test data set. Trained data set 70% to 80%, test data set 20% to 30%. Both will work out, no issues. Okay, after this very important step, fifth step, collect the data, clean the data, feature engineering, split the data, then tell me, sir.
Deployment.
No, no. Train model, test model, train model, test model. Already data is available now. You have the splitted data. Already you have the data set and you already splitted it to trained set and tested set. Now you have to train the model. You train the model with the training data set. You test the model with the test data set. You train the model with the trained data set. You test the model with the test data set. After this, sixth step, evaluation. Evaluation, something like what? Evaluation. Evaluate model. Evaluate model means, what is evaluation? What is evaluation? Result. Evaluation nothing but result. Result nothing but accuracy. Accuracy. Accuracy check. Accuracy finding is evaluation. Accuracy finding is evaluation. We want how much accuracy for this model with the data set? Trained data set and test data set. How much accuracy I want in the testing part? Score. Score how much I want. Not like pass mark. Not like pass mark 35. It will not work out. The kind of machine learning algorithms, it will not work out. You have to check the accuracy 98 to 99%. What is that? It should get the accuracy 98 to 99%. Evolution, model evolution. This model is fit for this data set or not? I am checking this model is fit for this data set or not. If this model is not fit, I can go with another model. If this model is okay, fine, accuracy is 98 to 99%, then okay, this model is very good. I can deploy this model for this application. That application have these kind of attributes in the feature real time. This kind of data will come, and this model is perfect, and this model give the proper result and proper output for me. That is the kind of evolution, guys. Finally, after evolution, what we have to do? Anyone? After evolution, what I want to do?
Deploy.
Hmm?
Deploy.
Deploy. That is the last concept. Deploy the model. Deploy the model for what? Where we have to deploy this? Deploy this model for what? Application. Any kind of application. Deploy the model for the web application. Deploy the model for mobile application, or deploy the model for any kind of application. It may be some car related application or watch related application, any desktop application, whatever it may be. You have to deploy the model for this applications. Okay, apps. I hope everybody got understand this workflow of machine learning, and what are the different kind of supervised learning models, what are the different kind of unsupervised learning models, and what are the different kind of reinforcement learning models. If you people have any questions, you can ask me now. If you people have any questions, you can ask me now.
Sir, what is feature engineering?
Feature engineering, nothing but after removing the null values and all, we have to just display the content using by matplotlib, or you can just verify the content with Seaborn kind of visualizations kind of thing. That is something like feature engineering. So when I write algorithm, you can understand. I will write step by step. If I write Python algorithm with the data set, I will write step by step what the workflow, how we have the data, how we clean the data, how we go with the feature engineering, how we go with the split kind of thing. This is very simple, straightforward. Every library in the scikit-learn, for every model, uh, different kind of methods are available. For linear regression, different kind of models available, different kind of methods available. Even for logistic regression, we are having different kind of models. Even for the decision tree, different kind of methods. Even for random forest, different kind of methods. KNN, different kind of methods. Navi basis, different kind of methods. We will discuss all these methods in the practical way. No worries. Theoretically, this much is enough. Theoretically, you have to understand this much. What is supervised learning? What are the different kind of super learning models? What is unsupervised learning? What are the different kind of unsupervised learning models? What is reinforced? And what are the different kind of applications in the reinforcement in the real time? Okay, I just want to give you a small, simple explanation for each and every algorithm now. This is clear, guys? Can I save this picture? ML, okay, supervised. Let me write ML types algos. Okay, this folder also I will share with you, all your email IDs. This folder, whatever the images I am creating here, whatever the theoretical images I am creating here. I already, sir, mute. Dilip, already I shared, uh, what is this called? IPNI file. I already shared a collaboratory file for everyone, but today I will share this folder also. Whatever the images I am creating from few days, the theory is very, very important over there. This is very much important to understand each and every algorithm in the future. Okay, next, I want to give a simple popular ML algorithms with simple explanations, guys. Okay, the first one, linear regression. The first one, linear regression. For the linear regression, what is the concept of linear regression? How linear regression will work? I already told you, na? I already told you what are the different kind of application for linear regression. Maybe price predictions, price predictions, then salary predictions, salary predictions, then speed prediction, speed predictions. Hmm. These kind of applications you can able to work with the linear regression, with the linear regression model. Am I clear? This is the linear regression model. The second one is logistic regression. For logistic regression, uh, what is the kind of applications we can able to work with logistic regression? Logistic regression. Sorry. Yeah. For logistic regression, the second one is logistic regression. What we can do with the logistic regression? Predicts. What kind of prediction here? What kind of predictions here? Predicts. Yeah. Predicts. 0 or 1. Yes or no. 0 or 1. Yes or no. True or false. This kind of boolean value. This kind of boolean value we can able to predict here. This kind of boolean values we can able to predict here. That is a kind of logistic regression. Okay. In examples, you can understand in uh, Python Python library, when we use Python library, and what kind of data I'm giving, and how we are predicting this 0 and 1, I will tell you. Sir, for example, COVID data you take, COVID data you take, or you take a bunch of items, or a classroom. In classroom, how many girls are there, how many boys are there, a kind of situation I want to check it out. So there is a one more thing, a third one, decision tree. After logistic regression, decision tree. Decision tree only, na? What is that? Just check the previous architecture. It may be a decision tree. Linear regression, logistic regression, then decision tree. That is correct. Now decision tree. Decision tree. How the decision tree will be? It is a tree-like architecture. It is a tree-like architecture. Tree-like architecture or tree-like structure for classification. Classification. What is the difference between the regression and classification? What is the difference between the regression and classification? Anyone? What is the difference between the regression and classification, guys? Linear regression, logistic regression. Those two are regression models. But this time, the decision tree is classification. What is the meaning of classification here?
Separation of categories, basically.
Separation, category separation. Category separation is a classification. Based on the attribute, some output predicting is regression model. Based on the attributes, some output is predicting, some value is predicting, some result is predicting. That is the regression model. And decision tree, based on the attributes, based on the patterns, you're classifying the data, you're dividing the data, you're separating the data. That is called classification. Decision tree is classification model. And one more three, random forest. Random forest is more than decision tree. Random forest is giving more accuracy than decision tree. Why? Because this is having some forest kind of structure, multiple trees which are available in the random forest. Random forest. In random forest, more accuracy for classification. Multiple trees, more accuracy for classification. Multiple trees, we will generate multiple trees. We will generate 100 trees. We will generate 200 trees. We can generate 150 trees. For the each and every tree, different attributes we pass. For the first tree, I pass a few attributes. For second tree, I will pass some other attributes. Third tree, I will pass some other attributes. So check the average of all these trees. I can able to get the more accuracy. Multiple trees you can able to generate, and more accuracy you can able to get here. More accuracy you can able to get here for classification. Random forest is also classification model for classification. This is also classification model. And one more thing, KNN. After random forest, there is a one more thing, KNN. How the KNN will be? How the KNN will be? K nearest neighbors. This is also for classification. KNN finds nearest neighbor. Finds nearest neighbors to classify. Neighbors to classify the data. This is also classification model. This is also for classification. This is also for classification. KNN also for classification. Remember, KNN also for classification. Right. There is a one more thing, SVM, support vector machine. Sixth model is SVM model. Sixth model is SVM model. SVM is nothing but support vector machine. Support vector machine. Then what is this SVM? How we can able to go with this SVM? Draw the best fit line. Draws, draw best line. Draw best line to divide the data. To divide the data. Draw best line to divide the data between the classes. To divide the data between classes. Between classes. Yes. Support vector machine. Draw the best line to divide the data. Sorry, this one is spelling mistake. Divide data between classes. There are huge number of classes. I want to draw a line between the class to class, class to class. So draw the best line to divide the data between the classes. That is a support vector machine. Okay, that is the one more model. Important, remember. Then seventh model, Navi base. Seventh model, Navi base. Let me go Navi base. Navi base. You can call base or you can call base, whatever it may be. Navi base. What is this? Based on probabilities. Based on probabilities, it can divide the data. Probabilities. Okay. How many know? How many people know about the probability in mathematics? Probability. If you spin the coin, what is the probability of spinning coin? What is the probability of spinning coin? Sir, probability of spinning coin, sir.
50-50.
50-50. It may something like 0-1. Head
Oh.
trial. Probability is 2. Two outputs, two outcomes you can able to see. Only two outcomes you can able to see. Am I right?
Yeah.
What is the probability of dice? 6-face dice or 4-face dice? What is the probability of 4-face dice?
25%, 0.25, 1/4.
It means probability is something like 4 dice, 4 sides, 4-sided dice. 4-sided dice. If I spin 4-sided dice, 4 into 4, 16, 16 occurrences it may come. 16 occurrences. Am I right? 16 occurrences. 4 4s are 16. What is the probability of 6-face dice?
36.
Obviously. So like that, we can able to work with this Navi base basically. So later we will discuss about this also. This based on the probability we can able to get the accuracy. Next, we can go through the one more thing. K-means. K-means. Yeah. Yeah. K-means. What is the K-means clustering? This is also clustering model. K-means. What is the meaning of K-means? Group similar data points. That's it. Group similar data points. Similar data points. Okay. For example, there is a data which is a combination of animals and humans. There is a data set which is a combination of humans and animals. How you can able to divide the data animal and human? How you can able to divide the data animal and human? The first priority, the first attribute, number of legs. Number of legs. Based on the number of legs, if a object have number of legs 2, it is human being. If an object have number of legs 4, that is animal. Am I clear? Am I clear, guys? Here K means clustering, group similar data points into the one category. Group similar data points into the one category, that is a k-means clustering. Remember this. Next, come to one more important thing, PCA. PCA analysis. Okay, PCA means reduce features for the fast models. Reduce features. Okay, the last one I just want to give. These are the important models which are going to be available. I just given the important models here. Remaining we will see in the programs. That is not an issue. This one I will go through the one more color. PCA. What is the meaning of PCA? Dimensionality reduction. Reduce features. Reduce features. There are huge number of features are there. I don't want to use all the features to find out the classification. Just go with the reduce features. Reduce features and check with the accuracy. Don't go for the number of features. Don't go for the number of features. I just want to reduce the features for the faster model, faster execution. For example, sir, there is a application called voting analysis or voter analysis. For voter analysis, we want to find out the data, uh, women and men, not child, women and men. Women and men data we are actually gathering. Who voted, who not voted, I want to check it out. Who voted, who not voted, I want to check it out. So for this, I don't want to take the number of kids available and what is the asset of the person and what is the age of the person. Am I need age of the person? First of all, he will vote means he is more than 18 years. That is already done. Now he is eligible for the vote. But I don't want to see the age of the person. I don't want to see the number of kids for this person. I don't want to see married or unmarried. This kind of features I don't want to give for the model. Model need all these things, huh? Model need all this number of additional features, huh? But when you get the data, that have n number of features, n number of attributes. But for the model needed what? Model needed what? For example, if I provide 100 features, execution is slow. Model execution is slow. Why? Because of this machine need to train 100 features, guys. It will take a long duration. But what with the PCA we can do? Dimensionality reduction. Dimensionality of the data set. Dimensionality means not number of records, number of features. Record is different, features are different. Features nothing but attributes. One simple example I already told you: voting eligibility or voted or not. I just want to check the status of vote in this village or in this town or in this city or in this constitution. There, those kind of unwanted features who needs. Am I clear, guys? Am I clear?
Yes, sir.
Okay. So in real time, using by this machine learning, what kind of applications, what kind of use cases we have? I just want to give some use cases, not all the use cases I'm writing here. There are huge number of use cases in the real world which are available for the machine learning, but I need to give some use cases here. What is happening, guys? This one. I want to give some use cases. Any use case you tell? Any use case you tell? You know where machine learning is using in the real time? Where machine learning is using real time? Something like fraud detection, something like credit card fraud detection. The one more thing, spam detection in the Gmail, all the spam mails will go to the spam category. Gmail already working with ML inside. spam detection, stock price prediction, stock price prediction, stock price prediction, and one more use case, chatbots. Yeah, we will have LLMs later. There we can understand about the chatbots. We will prepare one chatbot also. Fifth one, this one, fifth one. LLMs, RAGs. We will discuss Google Gemini API, all these things later in the coming classes. That is the Gen AI. And sixth one, chatbots is the image recognition. Image recognition. Seventh, number plate detection. Number plate detection. Sir, already governments are using this machine learning for the number plate detections using by the sensor data. Okay. Then one more thing is medical diagnosis. Medical diagnosis. Medical diagnosis. The one more is movie recommendation using by the Netflix. Movie recommendation. Movie recommendation. Something like Netflix. You have the different kind of OTT platforms now. You have the different kind of OTT platforms. Am I right? Netflix is there, Amazon Prime is there, AHA is there, and there are multiple things. Okay, movie recommendation like you can take examples of Netflix. Netflix already using this ML. Even Prime already using this ML. Even this AHA is already using ML. And something like Z is already using ML. Something like Ma is already using ML. There are different things, different online OTT platforms using the machine learning inside. Definitely, definitely. And some more examples, for the ML. Social media, social media, friend recommendation, social media friend recommendation, social media friend recommendation. How this social media is recommending you, your friends, something like your group of linking friends. He's your friend. He is already a friend of your friend. That is a kind of recommendation. Facebook is recommending friends. Even this what is this called? Instagram is recommending friends. Even Twitter is recommending. For example, uh, you added Narendra Modi in the Twitter. Automatically, a group of people with Narendra Modi will come to you. It is recommending. Application is recommending you a category of the person. He's the political person. Automatically a number of political persons are recommending to you. Or you added Shah Rukh Khan, automatically a number of Bollywood actors recommending you. Am I clear, guys? How this is happening in the application? How this is happening with the application, in the application? That is with ML. That is with ML. Social media friend recommendation system. And one more thing, very important. Self-driving cars. Self-driving cars. Yes, self-driving cars are ML application. Hmm. Any other use cases, Any other use cases? Agricultural, 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 uh, pesticide recommendation. In agricultural, there are n number of applications are there. In agriculture, there are n number of applications are there. You will be having this one is available in the agriculture. This will be available in the medical. This will be sorry. This is medical, na? Sorry, I have medical. spelling mistake here. You can just check it out. Where is the eraser? Let me write down medical diagnosis. So medical diagnosis. This one is medical diagnosis, right, guys? Okay. Let me erase this also. Maybe your picture is not looking good. Sir, you write down the notes. Write down the notes of the today's class. Why? Because today's class is very, very important for the machine learning enthusiasts, or for this generative AI also. For the generative AI, deep learning is most important. Okay. Anyway, I will teach some machine learning algorithms with you, and I'll go through the deep learning algorithms, CNN models, ANN models, RNN models. Okay. Then for generative AI, completely depending on deep learning. Some CNN models, RNN models, uh, ANN models. Okay, that also we will discuss. But I have to go through few examples in the tomorrow class. Tomorrow class, I done this kind of models. Maybe day after tomorrow, Friday, we will start deep learning. We will start deep learning. Okay. Medical diagnosis. Medical diagnosis. Yeah. Now this picture is clear. Any questions on this picture? Any questions on this picture? Please let me know, guys. Any questions and queries on this picture? Amarnath, Dilip, Divya, Karthik, Likit Kumar, Mansa, Rohit, Sandeep, Shashank Sudesh, Shravan Kumar, Shreya, Subodh. Any questions on this diagram? Explanation about the ML models. ML
No, sir.
models. Explanation. Okay. Explanation. That's it. This is the diagram for that. And tomorrow, what we can do is we go to the collaboratory. Tomorrow class, we go through the collaboratory and we will find out each and every example, how you can able to check the output for each and every example with the train test and accuracy, train test and classify, train test classify, train test classify with linear regression, logistic regression, decision tree, random forest, KNN, SVM, Navibase, K-means, PCA. And we will do a simple use cases also. We'll go through the simple use cases there. Then maybe day after tomorrow, I'm going to be starting with deep learning. Deep learning, what are the different kind of deep learning models are available? Deep learning is a subset of machine learning. Remember, yesterday I told you, na? Yesterday or day before yesterday? Yesterday only. Deep learning is a subset of machine learning. Machine learning is a subset of artificial intelligence. Now, ChatGPT is subset of deep learning. Come to the point. Sir, your AI changing the faces. Your AI previously available with ML models, later DL models. Later inside the DL, this Gen AI. And one more thing, agentic AI. Agentic AI, Gen AI comes under deep learning. But deep learning is the subset of ML. That is the very reason I am exploring the ML. I already told you some prerequisites to learn this Gen AI. What are the prerequisites? One is Python, one is ML, one is DL. Python, ML, DL are prerequisites to learn the Gen AI. Directly, if you go for Gen AI, you can't able to understand anything, sir. So I am starting Python from scratch, from 2 plus 3 execute. There onwards I am coming. There onwards, till Gen AI, we will cover in the classes. With the Gen AI, LLMs, RAG models, a different kind of other models also. With the Google Gemini API key and some other different other keys also we will use. Meta keys and all, Facebook's Meta. Okay, so any questions and queries so far further, guys? Let me know, guys. Amarnath, Divya, Karthik, Likit, Manasa, Rohit, Sandeep, Shashank, Shriya. Okay. See you signing off. Have a good day. We'll meet tomorrow. And any questions? I'm not right. Customer care, yes, exactly. Shravan, customer care is also there. Please like the video, share the video, subscribe the channel. If anybody not subscribed so far, please click on the bell icon for the further notifications. Provide your valuable comments in the YouTube. I will upload the video in the YouTube, guys. Have a good day. See you signing off. Bye bye.